First of all, Viking is a fantastic venture, and I mean that literally. It's probably the most sophisticated spacecraft ever designed for any purpose. It's going to Mars, it's going to land on Mars, and it's going to orbit around Mars at the same time.
I think Viking is one of the most ambitious projects ever conceived by the mind of man. I mean, it's incredibly complicated and audacious in its design.
For the Viking mission to Mars, this mind of man is concentrated here at the Jet Propulsion Laboratory in Pasadena, California. The mind of man and woman, scientist and engineer. They've come here from all over to control the mission, to ask the questions, and to try to make some sense of the answers.
It's a mission that has been designed and implemented under a great many constraints. And besides the obvious financial ones and the payload ones, the biggest restraint of all is, of course, our ignorance.
And that's been the problem. Not enough is known. Seeing the mission displayed on an outdoor status board, it all looks simple. But that's deceiving. The trip to Mars is an incredibly complex operation. The orbital mechanics alone are staggering. The techniques of getting from here to there and being there at the precise time. A year-long trip, on time, on target. The trip began in the summer of 1975. First one spacecraft, then another, launched toward Mars by Titan Centaur rockets, the beginnings of a voyage of exploration and discovery.
It's like the days of the Vikings, the real Vikings, as opposed to this Viking. It's an exploratory program, and we are asking new questions, and new questions always produce more new questions, and this is how you learn.
The early pattern of flight is familiar to space watchers. The initial thrust from the first stage, and then the second stage taking over, ramming the Viking through the skies on its way toward Mars. A long, looping journey of more than 500 million miles. Once on its way, the solar panels unfold, capturing the energy of the sun, energy used to power the intricate and delicate instruments aboard Viking. For guidance, the spacecraft seeks out and then locks onto the sun, and later to the star Canopus. From this point on, it's a stable cruise. Still flying together, the orbiter module does most of the work. The lander conserves its strength for the trip down to the surface. The mission, in all its intricate phases and steps, is controlled from Pasadena, the end product of years of research, training, and experience with other space flights. Just outside this room, standing by, are the scientists, the people who framed the questions for Viking to ask.
Well, we're now reaching the point where, of course, the activity reaches a peak. We've been cruising from Earth for roughly 300 days, and we're about to arrive at the planet, and that is, of course, the real payoff for Viking. And we'd like to think in terms of 2 spacecraft and 4 vehicles, 2 flying spacecraft, orbiter-lander combinations, which, when the landers go down on the surface of Mars, will separate from the orbiter. They're separated in terms of their encounter time at Mars by roughly 45 days. The first combination gets there on the 19th of June, and the second one follows on the 7th of August. The reason for the separation is fairly general. We have 2 basic desires in separating the 2 spacecraft. First of all, we would like to be able to use some of the information that we gained from Mars in the first spacecraft in order to get more out of the second mission. And secondly, we have, as you might expect, a general resource problem that afflicts everyone else. Our staff, computers, facilities, and so forth are really only able to handle 1 active landed mission at a time. So backing up, from June the 19th to July the 4th will be a torrid period of time here, and we call that site certification. Site selection is what some people think it is, and we don't have enough time in the project to go into an all-up, everybody vote, where do we land kind of process. And the idea runs basically like this, for the overall philosophy for site certification. We will put the first lander down at what we believe is a safe place. That is, a place where we think the engineering systems have the greatest amount of margin and that the probability of error in our particular understanding of Mars is reduced to a minimum. Then, if it goes down successfully, as we expect it will, and we then therefore have an engineering success for the mission, we can be a little more creative and a little less conservative with the second mission.
This engineering success is also built on years of trying and testing the precise steps on Earth that the real Viking will undergo on Mars.
2 hours before touchdown, the lander will separate from the orbiter. It has some very small retro rockets that are fired, which cause it to come out of orbit. At that time, it'll be reaching the atmosphere at approximately 200,000 feet. Then at approximately 20,000 feet, a parachute will be deployed. The lander will come down on the parachute to approximately 4,000 feet. At that altitude, our radars should have acquired the ground. They should have computed both our vertical and horizontal velocities. We have 3 small retro engines that will ignite. The parachute will be jettisoned, and under control of the radars and the onboard computer that we have inside the lander, we will make a completely automated landing. The engines will burn until the first landing leg has touched the ground, at which time they both turn off. And I would like to stress the word automated. We are, communication time-wise, 20 minutes away from Mars. It takes a radio signal that long to travel from Mars to us. So, in fact, all we can do is watch. By the time we're told that the lander has landed, it will really have been sitting there for 20 minutes.
We land in the late afternoon on a Martian day, and within seconds after the landing, we acquire the first 2 pictures taken from the surface of the planet. And these 2 pictures are then radioed back, essentially, real time to the Earth, and will be available, if all goes well, to the entire public within several hours after they're first acquired on the surface of Mars, which is an amazing feat. And those 2 pictures, I think, are the ones that perhaps we should talk about in some detail. The first picture is perhaps a little surprising to the layman, in that it's taken looking straight down, as close as we can to the spacecraft. And the reason for that is that we're anxious to resolve, as well as we can, with the maximum discriminability, the surface materials that exist on Mars. We're also anxious to look at the footpad, to see, if you will, the interaction of the footpad with the Martian surface materials. The second picture is the one which perhaps people will more anticipate. This is what we call a survey picture, which is taken in a lower resolution, and it extends all the way out to the horizon. So vicariously, everybody will have this opportunity to stand on the planet Mars and to look around just as he would if in fact he or she were standing on the planet.
They call them imaging instruments. They're cameras, facsimile cameras, and they're far different from any cameras we know. The camera scans, and small picture elements that make up the total image are recorded in sequence. The mirror moves down one vertical line. The camera then moves horizontally for another scan. These vertical lines are laid down side by side until a full image builds up. For this, too, testing has been intensive. Out in the Colorado desert, they tested the imaging system time and time again. The camera moves and scans, photographing the desert landscape, just as it will on Mars. The images are built up, aided and abetted by sophisticated techniques, complex technology. In their final version, they emerge as prints, just like those from the photo shop, almost. It took 10 minutes to complete the build-up which made this picture, startling in its clarity and detailed in its resolution.
The thing is that no one has ever looked at Mars close up. No one has the foggiest idea whether it will be a featureless landscape from the lander footpods to the horizon, or whether it will be filled with astonishments and delights.
They designed the cameras, tested them, and then took pictures of themselves, to their own astonishment and to their own delight.
Without apology, as far as I'm concerned, when I look at these pictures, I will be, I think, standing on the surface of Mars. It's as if I That's as close as I'll ever come to stand on the surface of Mars. Then I'll be looking out there, and I suspect seeking or expecting, hoping to see objects that are of real interest. Well, what's an object of real interest? I guess that's the excitement. We don't really know.
We soon may know. Through earthbound telescopes, Mars is a fuzzy, hazy red globe. But in recent years, we've come to see it better through the camera eyes of the Mariner spacecraft. The first close look, July 14th, 1965. Here on Earth, they found ways to sharpen their images. Consider this picture of a crater with interference patterns. They isolated the patterns by computer, subtracted them from the picture, and got a view of startling clarity. Since those early days of exploration, there's been a staggering array of pictures, each in its own way contributing to a growing body of knowledge about Mars. And now, Viking. The lander and the orbiter both are packed with instruments to conduct a number of important investigations. Investigations which cut across the lines of geology, meteorology, chemistry, biology, and others. Investigations which pose questions. Questions about the forces at work under the surface. Forces which have caused volcanoes, studied from far away and close up. Some of the pictures have shown us staggering features. Coprates Canyon, immense, dwarfing anything we know on Earth. And fields of sand dunes, spaced a mile apart, examples of large-scale depositing by the wind, and other sand dunes longer than any in the Sahara Desert. Huge craters, as big as anything on the Earth or the Moon. These pictures have brought tantalizing views of Mars and of its satellite moons. Phobos, a craggy oval only 13 by 16 miles, and Deimos, smaller and farther away. It too is heavily cratered. Volcanoes, craters, and rills, evidence that Mars, at least at one time, was an active planet, and questions about its atmosphere. There's extensive erosion on the surface, and it's important to know the cause. Strong winds howl across Mars, at times causing huge dust storms that obscure even the major features of the planet. Mariner 9 surveyed Mars during a great storm and photographed swirls of dust which obscured details on the surface. This picture of Nix Olympica was taken as the dust storm subsided. Nix Olympica, a giant volcano, 3 times larger than any on Earth. While the lander is on the surface, with its instruments working, the orbiter will circle the planet, taking pictures, conducting its own investigations. It will check for water vapor in the atmosphere and for temperatures on the surface and in the air. The orbiter is also involved in imaging, picture taking. Even before the lander touches down, the orbiter will verify the landing sites pinpointed back here on Earth. Throughout its mission, it will provide high-resolution pictures. The orbiter also serves as a communications station. It receives signals and commands from Earth and sends back to Earth information, data it has gathered itself and that collected by the lander and radioed up for relay back to Earth. And always the question of water. The South Polar Cap, frozen carbon dioxide, or a layer of water ice, or possibly both. Scientists, some scientists, believe that at one time there was free-flowing water on Mars, and they point to pictures such as these, a channel just north of the equator, possibly caused by free-running water sometime way back in the geologic past. The search for water is important because it may indicate the presence of some life forms, either now or at some time millions of years ago.
Whenever one talks about Mars, of course, the question of water comes up. And I guess unless you've traced the history of man's view of Mars, you really can't totally appreciate the significance of the discussions of water. obvious relationship comes in immediately in the mind is that water is somehow related to biology. The big argument with respect to water is something that Josh Letterberg calls bioavailable water, water which can be used by biological organisms. Now, almost everyone agrees that there's very little likelihood that there is free, pure H2O in liquid form existing anywhere on the Martian surface for a very long period of time. However, in a lot of the general theories which state that perhaps there's a frost that falls at night, and it's frost on top of like a permafrost on top of the ground, when the sun comes up, as the heat exchange begins, it goes through a very quick liquid phase. Organisms have been postulated that are so smart and their bodies are so tuned to temperature and other such things that they glob on to that liquid water when it's in that liquid phase, and therefore they use all the water that they need from that particular phase. Other people who talk about bioavailable water say that there's no reason whatsoever to believe that organisms have not learned how to use ice, to take ice directly into their system, which would allow them to use the permafrost. And some of the less earth chauvinistic, if I can use that phrase, people suggest that there may be biological kinds of action in saline pools which can survive in a liquid form and at temperatures much, much lower than those that freeze normal water, similar to the situations that exist down in the Antarctic and in Siberia, where there are liquid solutions which are down in 40 to 50 degrees below zero, and there could conceivably be, after a long evolutionary cycle, some kind of biological life which could exist under those particular extremes.
Some of those extremes are here, in Antarctica, the frozen continent. This is Don Juan Pond, a wide and shallow lake in Taylor Valley. It's a stark and bleak place. Along the shores, huge salt crystals form because the water is comprised mostly of calcium chloride, 42% solids. And yet, in this weird, strange place, there is life. Scientists first went there in 1961 and found 4 live microorganisms, 3 types of bacteria, 1 species of yeast, growing in heavily saline water at below zero temperatures. Not far away, in another of the Antarctic dry valleys, there is different water, meltwater from glaciers, and in its presence, there is more abundant life, abundant for Antarctica. Algae, mosses, and lichens. Scientists speculate that if life can grow here, then there's a possibility that it has developed and grown in other hostile places. Viking will ask a lot of questions, cover a lot of scientific ground, but the focus of attention is on the search for life. And this strange-looking device will do the spade work. In a room near Viking Mission Control, they operate a full-scale test bed model and cause it to function exactly as the real ones will on Mars. It's strange looking and strange sounding, too, as it uncoils itself from the lander and stretches itself out, unrolling and unfolding, preparing to drop down and dig up samples from the soil.
There are 3 experiments in the so-called life detection package. One of these is a gas exchange measurement, which will simply look to see whether samples of Mars soil modify the composition of a piece of Mars atmosphere that's brought into contact with it. There's another experiment which is based on the idea that we might be able to detect the fermentation of substrates that we give to samples of soil. And then finally there is an experiment to test for photosynthesis.
Again, it all appears simple. The soil sampler scoops up its samples and deposits them in one of 3 chambers, which are, in effect, miniaturized laboratories, each one asking different questions. Those questions all relate to the big question, Is there a form of life on Mars? Two answers are possible right away. Yes, there is, or we don't know. The third answer, no, may take a long time. This may not be the right spot, or the experiments may be asking the wrong questions. The matter of life ever existing on Mars in the past will take even longer. Whatever the immediate short-term answer, those who've been waiting will feel that it's worth all the effort and the expense.
But the thing that really turns me on is the idea that there might be a separate and distinct origin of life on Mars. You know, if you really had it happen twice in this tiny little sun solar system that we have, two adjacent planets, the same geological time frame, both independently started life, why the universe must be teeming with life. And if that's true, who are we to say that we're the smart ones? You know, we may be somewhere in the middle. One is always in the middle of some curve.
And we play the statistical game that's played with stars and planets and how many millions or billions of them are there and how many of them should have produced life. And as you know, it turns out that you end up with literally many millions, at least, of planets that should have evolved life.
I realize it sounds kind of science fiction, but the fact is, these things are not inconceivable. The numbers drive you in the direction where you're forced to believe that if there's an independent form of life on Mars in our time frame, it would not be unwise to listen in the heavens for coherent signals, to listen in on other civilizations.
For now, though, it's enough to listen in on Mars. One day soon, the real thing will happen. The soil sampler will move down to the collection chambers and shake and rattle as it sifts the soil into the containers. And then, the waiting will be over as the answers begin coming back. In the Viking search for life, there are 3 investigations, each based on different assumptions about life on Mars, what it might be, what it might require to live and grow. The soil samples will be incubated in different environments, in these miniature laboratories, then analyzed, then reported. All the instruments have been sterilized. In fact, the entire spacecraft. So there's little possibility that Viking will be examining life forms it brought with it.
What's interesting to me, though, is that the 3 sub-investigations in the biology experiment have each taken a different tack with respect to what I would call its Earth chauvinism coefficient as to what life might be like on Mars. Clearly, we do not know, and clearly the instruments had to be designed in a certain sense to be based upon our assumptions of what life there may be like. However, the 3 experiments run the gamut. In one of the investigations, we feed whatever it is we're trying to grow Mars conditions and see whether or not they grow in exchange and so forth. In another one of the 3 experiments, way over on the other side, we basically feed these organisms that we're trying to grow Earth conditions, nice nutrients and other such things that Earth organisms like and thrive in. And then the 3rd investigation sort of hedges its bets in both directions and gives it a little bit of Earth kind of stuff, but not too much, and a little bit of Mars kind of stuff. So that basically the biology investigation allows you to look at 3 different approaches to organisms, be they Earth, Earth-like or totally Mars-like or maybe somewhere in between. We, of course, recognize that we cannot be completely clever and figure out a way to absolutely identify whether or not there's life there, but there seems to be some balance between the investigations.
For meteorology, DEXA takes the meteorology data and throws out...
They have framed the questions. They've designed a mission of incredible complexity. And they've dreamed and imagined and built a spacecraft even more complex. They keep tabs on their plans. Their schedule tells them that Viking 1 is due to touch down on July 4th, a sort of birthday present to the nation if all goes well, and Viking 2 on September 4th. That's the schedule, planned months ago. So now, they can only keep the vigil. The people in this room know more than their predecessors. They've been there vicariously through earlier picture-taking spacecraft, also sent to Mars by NASA. Yet, they really know very little, and that's why they wait. They may know a great deal soon, and they're not unmindful of the importance and the excitement of what they are doing.
We are the only people who will ever be the first to explore our solar system. We are doing it now, and that is what Viking is really all about. The major questions as to whether or not there's life on Mars, whether or not there ever was life on Mars, or whether or not Mars could support life, are certainly very, very important from a scientific viewpoint. But the overall integrated picture of another planet and the possibility of anything living on it, of course, is part of that. And how that picture puts together that which we think of, or how we think about the Earth as a result of that, to me, is the real payoff of Viking. It's particularly important for me, if I can throw a personal note in, because right at the time we are landing on Mars, right at the time we are trying to discover whether or not there's life on another planet, I am also going through a personal experience, which is considerably interesting. I'm having my first child. And the two together has caused me to be in a state of wonder at life and excitement about what's going on that I never would have thought was possible